All right, let's go ahead and start on 1.2, scientific method. The scientific method is the process that we use and that scientists use to acquire new knowledge, to understand the questions of what's around us, what's going on, etc. And it improves our understanding of our surroundings. It improves our understanding of the universe. So, what is the scientific method? Well, you've had this since elementary, so we're not going to belabor the point too much, other than to say it is a precise way of using scientific thinking and experimentation to come to conclusions that answer those questions of the universe. So a lot of times we'll use these steps here. They may not be in this order necessarily. Generally in high school and when you're learning science, this is the order that you kind of do it in. But it's not exactly a cookbook formula, okay, that leads you, okay, mix this with that and mix this amount with that, and then you follow step by step. It's not quite like that, but it usually involves these steps. First, you have to have a question that you're trying to answer. Sometimes you may gather data and observations that leads to questions, okay, or you do an experiment and then you develop questions and then you further test it. So regardless, this is the order we're going to learn it in. You identify the problem. You gather data based upon that. Have there been tests before? What did they do? Did they do it wrong in your mind? Did they do it controlled as you would have liked? Did they account for certain things? Do you want to test something specific that they didn't test or they did test? Maybe you want to repeat their test to see if they're correct, etc. Then you come up with a hypothesis. Now, a hypothesis is a guess. Most of the time, you don't even come up with just one answer. Okay, you come up with options. Okay, you have if I do this, then this will happen, or it won't happen. And you do both at the same time. Which one you accept depends upon testing it. Of course, you test it and make sure that it's controlled. You can only test one variable per experiment. You can have multiple experiments going on at once, but each experiment can only have one variable that is different than what you're controlling, the control group. And then you go on and say, well, does this data agree with one of the hypotheses that I came up with? And then you go from there. You either revise your hypothesis or you accept it. And then you make it so that other people can go from there. Now, in the scientific method, there's a lot of misconception, a lot of things, some definitions and terms that people get wrong. Let's go through some definitions here. So first, scientific method. It consists of making those observations, basically going through the process I just showed you on the previous slide. And you continue to test those hypotheses if the observations do agree with it, because just answering it one time, was that a fluke? Maybe you just got lucky, or maybe you didn't get lucky in your data in your data collection. Maybe you didn't account for certain things and you're not creative enough at that moment to figure out that you didn't account for all the variables. All right, hypothesis. What is it? A lot of people use the idea that it's an educated guess. Now, an educated guess does not have to be right. Okay. In fact, it's just, something that you're thinking this is a possibility. Okay. Based upon the data, based upon my understanding, based upon, you know, education. Okay. That's why you gather data before you come up with this hypothesis. Now, most people get this one confused with theory. A lot of people say, well, I have a theory, or it's just a theory. Ugh, that bugs me. That drives me nuts. When you say that it's just a theory, you're actually saying that in scientific definition, that it is an extremely well-tested, synthesized, um, usually it encompasses many kind of concepts that kind of lead to one thing. For example, the theory of evolution, or the theory of the Big Bang, or the theory of subatomic particles, quantum mechanics, and things like that. These are things that it may not be perfectly correct, but through experimentation, it has always been shown to be correct, and you synthesize all of those concepts that have been proven to be correct over and over and over again, and then you have a theory. Okay, it is essentially a theory that has data, and usually tons of it, that supports it. It is not a hypothesis. It's not some whimsical guess. So, what about law? Well, usually a law is something simple. It's not the end all to beat all of understanding. Okay, most of the time it's some kind of mathematical relationship. For example, Newton's second law, okay, of motion. If I were to push on a boulder, okay, the boulder is going to accelerate based upon a couple things. One, how hard I push it, the force that I apply. Okay, but it also depends upon how big the boulder is. The bigger it is, the less it's going to accelerate. So you can set it up so that it's a relationship mathematically. Acceleration is proportional to the force and inversely proportional to the mass. We'll talk about that later. Relax. But that's what we mean by a law. It's something simple, sometimes quite profound, but simple, that can show a precise relationship between certain things. Okay? Um, it's not the end all to beat all of comprehension and understanding. Motion. Well, Newton's second law is a small part of all of the motion. Okay, you got to put them all together to get your theories. Okay, well, and then of course you have an experiment, and an experiment is something that you test. Okay, in order for something to be testable, I'm sorry, excuse me, in order for something to be scientific, it must be testable. Okay, so here's a great question for you. Which of these is a scientific hypothesis? Let me come up with a few. One, um, we will never step foot on the moon. Two, Einstein was the most intelligent scientist of the 20th century. And three, there are parallel universes to this universe that we have yet to detect. Which one of those three, or which ones of those three, or if any, was scientific. Well, what did I just say before I gave you the question? What was which? In order for it to be an experiment, it must be. In order for it to be scientific, it must be testable. And the only one of those three that's testable is the first one. Okay, we will never step foot on the moon. And that's obviously incorrect. We have. And don't give me this conspiracy mumbo jumbo. Yes, we have. But that is testable. Can we test actually stepping on the moon? Yeah, well, we've done it. We could do it again if we had to. Okay, so that's the one testable. All right, we're going to end it here. Kind of a short one. We'll see you in chapter 1.3 later. See you, gang.